This is AS1 Jun2009 question 2. State how to calculate the moment of a force about a point. So the moment about a point is equal to the magnitude of the force multiplied by, and I'm not writing this out properly, but you will because you'll have more space, the perpendicular distance from the force to the point, or from the line of action of the force to the point. Name the SI unit of moment of a force. So if I just write down moment is force by distance, force is measured in newtons and distance is measured in meters. So they're not looking for base units, so you're happy enough to write down newton meters. Although I think they give you an answer, they give you a mark for it in base units, and in base units it's kg m squared. I'll write it down, kg m squared s to the minus 2. So you have, there's an alternative you could use. Figure 2.1 shows a stationary wheelbarrow is being supported by the gardener at this end, who applies a vertical force of 50 newtons at the end. The weight of the wheelbarrow and contents is 175 newtons. The force applied to the handles acts at a horizontal distance of 1.4 metres from the point of contact of the wheel with the ground. So you can see that there. Another force acts on the wheelbarrow at the wheel. State the magnitude and direction of this force. And so if I just draw this in, there it is there. And that's your reaction force up. And therefore the magnitude of it, if you know that 50 plus R, your upward forces, that's equal to your downward force of 175, then R is equal to 175 minus 50. And it comes out to be 125 newtons. And it is upwards, so I'm just going to write that on the next page. So the magnitude is 125 newtons, and it's up. Calculate the horizontal distance from the centre of gravity to the end of the handle. And so if you have a wee look at the diagram again, we know that this is, now you have to take your moments about the pivot, or about the wheel, and therefore you're going to, when you find your distance out, you're going to have to take it away from 1.4 metres. So you just need to be careful about that. So we're looking for this distance here first of all. And so we can tell, so our clockwise moments equal anti-clockwise moments. And our clockwise moments, if I go back to the diagram again, are 50 multiplied by 1.4. And the anti-clockwise moments are 175 multiplied by this distance we don't know. So when you do that sum, D comes out to be 0.4 metres. But that isn't the answer. The answer is the distance from the end of the handle. You probably would only lose 1 mark there. I should have checked, but if you had written 0.4. But the actual distance from the end of the handle is the whole distance from the pivot is 1.4, and then take away the 0.4, which is 1.0 metres. And that's your answer.